All right, checkpoint problem 3-67. This problem is a checkpoint for rewriting and simplifying expressions with integral and rational exponents. It will be referred to as checkpoint 3A. For parts A through D, rewrite each expression. For parts E through H, simplify each expression. So we have a list of problems here, A through H. It says check your answers by referring to the checkpoint 3A materials located at the back of your book. If you needed help solving these problems correctly, then you need more practice. Review the checkpoint 3A materials and try the practice problems. Also, consider getting help outside of class time. From this point on, you will be expected to do problems like these quickly and easily. All right, let's get started here. So for parts A through D, we're just looking to rewrite each expression. So, A, we're given the fifth root of x. So our fifth root of x, we're just trying to rewrite it. And if we recall here, remember the root is going to tell us that we're going to have a fractional exponent. In order to rewrite this, if we think about it, we've got the fifth root. Right now, x is being raised to the first power. So another way to write the fifth root would be like saying x to whatever power it is under here. Right now, it's just to the first power, raised to the power of 1/5. Our root power, our root number, remember, is our denominator of our fractional exponent. Now, if I took 1 and I raise it to the 1/5 power, using our properties of exponents there, we know that we're going to do 1 times 1/5, and it's simply x to the 1/5 power. Looking at problem B, we're taking this one and we're simply rewriting it. We have 1 over x to the third power. Well, if we wanted to rewrite it, one way that this could be rewritten is by getting our x to the third out of the denominator. We know that when we take it here and we write it outside of the denominator, move it up to the numerator, it should become x to the negative third power. Letter C, we have x raised to the 2/3 power. Well, I'm going to take my x to the 2/3 power and we're going to break it apart. Remember, we just looked at problem A and we said that the root was our denominator. So here, when we're looking at our root is 3, which means we're going to be taking the third root or the cube root. And our numerator here is going to be our power that our x is going to also be raised to. So if we take it and break it apart, we can look at it like this. Let me stay. That's better. All right, so I could take this and break this apart and say x squared to the 1/3 power. Think about your rules for exponents. If I take a power and I raise it to a power, I'm going to take this and I'd say 2 times 1/3. That should get me back to 2/3. Well, 1/3 here is the same thing as doing the cube root. What am I taking the cube root of? I'm taking the cube root of x squared. Now, if you chose to do this a different way, another way this could be written here is we could take x and raise it to the 1/3 power and square that, because using our properties of exponents, 1/3 times 2 is still going to be 2/3. So remember, multiplication is commutative. You could do either one first. If we think about x to the 1/3, that's still going to be the cube root. So we have the cube root of x in this case. Let me move my little box out of the way here. And we're still taking this and we are squaring it. So this is a second way that you could write this expression, x to the 2/3. So this is one answer, or you could use this answer. That's two different ways to write x to the 2/3 power. For letter D, we have 1 over the square root of x. This one's going to be kind of combining each of the things that we've done in the previous three problems. First of all, the square root of x can be rewritten as x to the what power? Well, this is the square root, which means it would be x to the 1/2 power. This is like saying 1 over x to the 1/2 power. And that would be one way of rewriting it. And we could also take it one step further. If we wanted to take our x to the 1/2 and get it out of our denominator, when we move it up to our numerator, what happens to our exponent? It should become negative. So we have x to the negative 1/2 power. So there is our answer for D. So here are each of our answers for this first part. Remember, it was just asking us to rewrite these. When we get into the second part here, we look at E through H, it said that we needed to simplify each expression. Remember, if an expression is simplified, there are no negative exponents. So we have no negative exponents when we simplify. So let's move on down here and take a look. Make sure we got plenty of room here. So x to the negative first, y to the negative 8th. If we want to simplify our expression, let's just go ahead and look at each part one at a time. X to the negative first power times y to the negative 8th. Well, x to the negative first power is like saying it's over 1, and y to the negative 8th is like saying it's over 1. If we want to get rid of our negative exponent here, remember that it's going to take it and it's going to move our x across our fraction bar into our denominator. Same thing with y to the negative 8th. This is like saying we're dividing by y 8 times. So this is 1 over y to the 8th power. When we multiply our two fractions together, we should end up with 1 over xy to the 8th power. Our second problem, or f, we have m squared raised to the negative 3/2 power. There are multiple ways that you could get to your answer on this one. One thing I would do here is I'm going to look at just using my properties of exponents here to just try to simplify this down a little bit. If I'm taking m squared and I'm raising it to the negative 3/2 power, that's like saying m to the 2 times negative 3/2. Well, 2 times negative 3/2 is going to be negative 6/2, and that should reduce to negative 3. So this is the same thing as saying m to the negative 3rd power. If we want to rewrite m to the negative 3rd power here and simplify it, we can't have this negative here, so this should end up becoming 1 over m to the positive 3rd power. For g, we have x to the 3rd, y to the 6th, raised to the 1/2 power. Now we could look at this as taking it and raising each one of these to the 1/2 power like we did on the one before, or we could use another method Let's go ahead and do that here. Remember, 1/2 power is the same thing as saying the square root of x to the third y to the sixth. So we're essentially taking the square root of each of these two variables. So when we look at x to the third, does it have any perfect square factors? We know that x to the third is the same thing as x squared, or let's say x times x squared. X times x squared gives us x to the third. Any exponent that is even is always going to be a perfect square. So we know that x squared is a perfect square. Y to the sixth would also be a perfect square here. It's like saying y to the third times y to the third. So when we look here, if we were to take these and break these apart, it's like saying the square root of x times the square root of x squared times the square root of y to the sixth. These two are both perfect squares. So you can take the square root of a perfect square, and what are we going to end up with? Square root of x squared is going to be x. Square root of y to the sixth is going to be y to the third. And the square root of x is just going to remain as the square root of x. Now to write it so that it's much easier to work with, if this was part of a problem, we need to take it and rearrange our order and put our radical in the back. So we would have x, y to the third, radical x, or the square root of x. That would be our simplified answer. Last one here, we've got h, 9x to the third, y to the sixth, all raised to the negative second power. For this one here, I'm going to go ahead here and I'm going to get rid of my negative exponent here by taking the reciprocal of this base. Remember, our base is 9x to the third, y to the sixth. If I had said this was just some number n to the negative second power, we would have said, okay, this is the same thing as 1 over n squared. We can do the same thing with this. This whole entire value here. It's like we're substituting our n in its place here. We would take it and then we would put it back in down here. So this expression would be the same as 1 over 9x to the third, y to the sixth, to the positive second power. And if we take this expression and we multiply it by itself, we know that we're going to be squaring each part of this term here. So 9 to the second power would be 81, so 1 over 81. X to the third squared, well, x to the third times x to the third is going to be x to the sixth power. And y to the sixth power raised to the second power, well, y to the sixth times y to the sixth would be y to the 12th power. So we end up with 1 over 81 x to the sixth y to the 12th power. That would be our final answer for this one. These concepts are concepts that require a lot of practice. If it's something that you don't feel like you have down yet, it is something that you definitely want to work on in order to be ready for the rest of the Algebra 2 course. So please see your teacher if you need extra practice. Also check the back of the book for the extra checkpoint materials. I hope this helps, and good luck.